Okay, I'm going to go over a few of these advanced problems from the distance formula. The explanations you get on Khan Academy will mostly be the algebraic solution to the problem. Okay, so I will not go through the algebraic solution because you can check that out in the problem itself. You can see them set up the distance formula and solve it that way. So I'm going to approach this from a little more of a visual perspective and helping you set this up. Okay, so we have the length of a line segment. PQ is 5 units, and P is at negative 2, 2, and Q is at x2, and we want to find the positive value for x. Okay, and so we can set this up. I'll draw a coordinate plane here. So let's draw ourselves a coordinate plane. Okay. So there's our axis, and P is negative 2, 2, so 1, 2. So here's negative 2, 2. Let's make that blue. So this is P. Okay, and X is at, or sorry, Q is at x comma 2. Okay, so we don't know what the x value is, but we know the y value is 2. Okay, and so this is the line y equals 2. Okay, any point on this line has a y value of 2. And so we know that Q is somewhere along here. And what we know is that this distance from P to Q is going to be 5 units. Okay. And so just looking at this, so the distance from P to this line, okay, y equals 2 is 1, 2, 3, 4. So this is already 4 units. So we know it has to be somewhere to the left of it or somewhere to the right of it. Okay. And so I'm going to sketch out the two possibilities. Okay, so we could have a line somewhere in this direction, or we could have a line somewhere in this direction. Okay, and they could both be 5 units long. Okay, but we want the positive value of x. So it's not hard to imagine that the solution is going to be this one over here. Okay, and that doesn't really matter for us now. But we'll find that we do get 2 solutions from this, and we can look at those. So now I'm just going to set myself up, because distance is really an application of the Pythagorean theorem, right? And so if this distance is my hypotenuse, then I know I can create a right triangle, okay, where I can call this side A, and I can call this side B, and I know that A squared plus B squared should equal 5 squared, right? Okay. So I can take that a little farther because I know this distance here. I know what B is. I know the distance from P to this line here is not actually B, but it is actually 4. Okay, so now what I don't know this distance here, so I don't know this A value. Okay, so I know that A squared plus 4 squared should equal 5 squared. And now we can solve this, so we get A squared plus 16 equals 25. Then we can subtract 16 from both sides. Get A squared equals 9. And if we take the square root of both sides, okay, we get A is equal to plus or minus 3. Okay, so this is telling us, right, A can be 3 units in this direction, okay, or 3 units in this direction, okay. So 3 units from point P's x value is going to give us a positive 1. So we're going to have a point here. This is going to be the point 1, comma 2, and that's going to be 5 units away. And there also is 3 units in this other direction, okay. So this is going to be at -5, comma 2, okay. And both of those lines are 5 units long, but we were asked for the positive value of x, okay, which is going to be this solution here. So the positive value for x is this 1 right here, and that is our answer.